It's Thursday, it's 4 o'clock, and here we are at login. So, what are we going to talk about today? A few exciting things, and I'm glad that you're here to learn more about risk with us. So, thanks for taking time out of your day to be here and learn, ask questions. If there's any questions, drop them in the chat. I'm going to do my best to come back and check on the chat as we're going along. So we're going to talk about a couple things first, right? I'm going to run through some diagrams and we're going to talk about actions and controls and how to implement and integrate them. So we've got this red line. This red line is what malicious cyber actors are trying to do, right? And what we're trying to do in our industry is reduce the likelihood and effectiveness of their attacks. And I know we're back to this screen. I was just coming to see if there were comments. So what we've got is a malicious cyber actor, and they're persistent. They're in business to make your life a little bit harder. So what do we want to do? We want to deter their efforts, right? We want to put deterrence in place to make them abandon their efforts. That's the outcome that we're hoping for with a malicious cyber actor. After we do deterrence, we want to make sure that we protect our data, right? We want to protect our data, our customers' data, our clients' data. We want to provide privacy, integrity, availability, confidentiality, and we want to prevent the likelihood of exploit or compromise on the data we have. Now, there's lots of ways we can do this. We can do this by ensuring that we have effectively secured our data, right? Applying access controls, applying controls to how the data is stored. There's so many things that we can do to protect our data, to prevent it from compromise. But to do that, we also have to be able to detect a malicious cyber actors' activities inside of our network. The great thing is computers will tell you what's going on inside of your network. So what we can do is determine how the organization will select controls, right? Proactive, detective, and responsive actions and controls. So what are we talking about here, right? Proactive is preventative things, right? Detective is a configuration that will raise an alert to somebody and say, hey, we detected something outside of the baseline that you told us to. And responsive is what you do when that control or that notification has occurred. So think about this. You're cooking in the kitchen and you smell something burning, right? Your response is to go and figure out what's burning. And then when you figure that out, you make sure to put the fire out or to stop the burning. Turn off the heat, use a fire extinguisher, so many options. Same thing with cybersecurity. Once we've established these things, we can move into adaptation. This is the most important part. Malicious cyber actors are out here every day trying to get through our deterrence, right? Get through our protection mechanisms and evade our detection systems. So we have to be aware that they are agile, adept, and flexible, and they will adjust to what we change in our environments so that they can be more a thorn in our sides. But we can work together to more effectively talk about risk and cybersecurity and really just do a better job of adapting to what's changing in our environment. Now, oftentimes people will say the technology has changed so much. Computer systems still have motherboards and processors, and the architectures have advanced a little bit, but ultimately, right, we've got the OSI model ranging from physical to then data, network, transport, session, presentation, and application. So across that whole stack, we have to consider where we can place a control to determine our proactive, detective, and responsive controls and actions our organization is going to take to ensure that we're protecting our data to prevent compromise and deterring malicious cyber actors to abandon their efforts. So what can you do? Why is security important, right? Security is one component of computer systems. And what's really important here is when you start to analyze your computer systems, we can move into a variety of spaces, right? We can move into inducing change across our systems. We can accelerate transition, right, to practice. We can take our conceptual things and start to actually practice them and implement them. Then, because we're using computer systems and they are just math machines, we can develop scientific foundations to really approach this solution, and we can maximize the research impact. When we can clearly articulate why we're selecting a control inside of our organization and who's responsible, accountable, consulted, or informed about that control, we can do things more effectively. So when we do that, it lets our organization start to induce change. We see opportunities. We see new new events. We see new opportunities inside of our systems that really empower us to be more effective technicians and operators. So that's what we're going to do when we are working on our cybersecurity programs. And additionally, we're going to take another dive into systems of systems analysis. And I don't think enough people in this industry actually talk about what systems of systems analysis is and how integral it is to making selective controls, why we're selecting those controls, and moving from them. So, what do we have here? We have our design model, which is made up of ideas and averages. Now, I want you to think for a moment and say, well, think of a truck in your mind and maybe take your time and draw that truck out, right? Maybe you can say, well, what does the truck look like? And just take your time with it. Now, once you have done that, right, think of a truck that isn't the model that you drew in your head, right? If you thought of an F-150, think of a Toyota Tacoma. If you thought of a Toyota Tacoma, think of a Datsun pickup from the 80s, right? We made these things from ideas and averages. It should have four wheels, a transmission, a motor, and some doors and windows, right? Ideas and averages. Most vehicles have those components, but you can structure those components different. Now, that's how you get the design. And once we go through the design, we go through what's called a design space and we get our actual system. Now, if we're going to talk about technology, what we can talk about here is this actual system is a system in your environment. It's a firewall. It's a web application gateway. It's some sort of system. Now that system is going to be impacted and it's going to differ a little bit from what was the idea and average, right? And that system is going to be placed inside your environment. Inside your environment, you have to consider a couple things. You've got variances and change and time. So the variances, one company chooses to do it version A, one company chooses to do version B, and another company chose to do a mix of A and B. So all of those are variables inside the actual system. And what we have is that organization will experience change over time. People quit, systems change, customer bases change. The organization grows or matures. The organization doesn't grow or doesn't mature. All of these are going to impact the actual system, and it's going to impact the operator model. Now, the design model should consider who the operator is, but it may not. But we're hoping that a well-designed model, right, considers what the operator is going to be looking at. Now, if you look here at the operator, right, the operator is going to be impacted by operational concerns. And we've got a typo here, so let's go ahead and just change that. Right, continuous improvement, continuous employment isn't difficult. Also, we're using a write once, read many format, leveraging Figma. So, right, we're able to come in here and make changes. I wrote it once. Anybody else who has access to this is going to be able to use it. So once we go from operations, we have procedures. Your company might do it different than others. My company might do it different than yours. And then when we go from procedures, we also have our organizational training. Some organizations have training that's internal, external. There's so many varieties, which is really going to impact our operators. If you have new operators on systems and they haven't been trained formally by your organization, I would encourage you to train them. So your operators are also impacted by a couple things. The actual system is impacted by experiences, improvements, and metrics. So an organization may say these metrics are important to us. These are our key performance indicators. These are our key risk indicators, or these are our key compliance indicators inside of our company. Every company is going to take a different approach because each one will have a unique threat model and each one will have unique experiences in the internet. So once we do that, we're going to have our operator model, and that's going to be based in reality, and it's going to have consequences. I frequently mention about consequences. Consequence-driven, cyber-informed engineering is the way to engineer your computer systems. If you don't engineer your systems with consequence-driven, cyber-informed approaches, you're going to have a difficult time, and it's going to continue to lead to these series of compromise. So what we're going to do here is we're going to determine the consequences. But how would you determine the consequences for your organization and your system, right? Well, it's not too hard. We're going to come up here and we're going to talk about consequence-driven, cyber-informed engineering and the three phases and the steps inside of those phases. So first, we need to set our objective. Then we need to set our scope. And then we need to set our boundary condition for how we're going to approach this work, execute, right? Engineer, install, operate, maintain, and defend our controls. This is imperative. If you take shortcuts in any of those 5 steps, your organization will be more apt to have an experience of compromise in a security control, and that control will be deemed ineffective. So we're going to set our objectives to select a security control. We're going to scope it according to each system and the risk of those systems. And then we're going to move to phase 1. What is phase 1? Well, let's dive into it. Phase 1 is where we're going to determine events that are appropriate for our company, our environment, right? What events are you going to experience where you are? If you're in an area that's not prone to tornadoes, don't consider a tornado in your event. But if you're in an area that's prone to fires, consider a fire as an event. And once you move to an event, we need to determine the cyber events. Cyber events vary by industry, region, type, service, customers, clients, the materials that you have, the software bill of materials, the systems and services your organization uses. So what we're going to do is take a really good asset inventory, look at the key vulnerabilities that can be exploited very easily or remotely. Again, we wanted to deter a malicious actor's efforts. And then we're going to score those. And we'll dive into that later, right? We'll determine how to build a score and a risk analysis. And then what we're going to do is we're going to move to phase 2. Phase 2 is interesting, it's exciting, and it's where you're going to build a really, really great team. You're going to build effective documentation, and you're going to move from phase 2, and you're going to start information gathering. So what type of information do we want to gather here? We want to gather our system diagrams, we want to conduct interviews, and we want to write better manuals. We want to make sure we have manuals for all the systems and all the components that we're using, and that's going to help us develop a system description. So we need those diagrams, we need the interviews, and those interviews should occur with the people who manage, operate, maintain, defend, and audit those systems. You should have a unique series of questions to ask each of those individuals and those teams to really understand better about how the organization functions and how that process can be disrupted by a malicious actor. Okay, after we've developed all of those components and we've documented them, we're going to come up here and we're going to move to phase 3. This is where you're going to actually do that technical work. You're going to establish your boundary conditions. You're going to talk about technical approaches, right? How are you going to do that work? We're going to determine the targeting details, right? What are we looking for? How are we going to find it? What are we going to do to mature that? And then we're going to find a system targeting profile. Again, this should really be scoped to your organization's current threat model. If you're not vulnerable to a certain malicious actor because they don't attack people in your space, don't consider their techniques, tactics, or procedures. Select security controls that are appropriately scoped for your organization and your environment. Remember, we established what those system components are. We scored our events, right, and our cyber events. So we should really have an idea about what our organization's priorities are. If we don't know, we need to examine and make sure we selected the right events, determined the right cyber events, and we appropriately scored them. So with that, we're going to develop our targeting details, our system targeting profile, and then we're going to move into critical needs. What does that system need to continue running, and what process could be interrupted that would disrupt the critical needs of the organization? This is your high consequence event. One user being logged out is not a high consequence event, but multiple users or all of your users being unable to access the service is probably a critical event. Again, if you have not done this for your organization, then I would encourage you to look within inside your organization and start doing this work. You can do it in as little as 15 minutes or 30 minutes for one meeting a week and take this insight and start to ask those good questions. You're going to go through your attack scenarios. You're going to determine the attack payload that a malicious actor might deploy. And when they've done that, you can appropriately set controls to log, monitor, and alert when something's happened. Then we move from attack payload to that high consequence event. This is your outage. This is your system interruption. And this is what we are trying to prevent from happening at our company. Really important that we focus on high consequence events and how to reduce them. So once we've done that, right, we're going to then move into scoping out and documenting all of that work. Again, we set our objective, scope, and boundary conditions for the work we're doing. We have a great understanding of the events, cyber events, the scores, systems diagrams, interviews, and manuals for an effective system description. This is imperative for your organization to be successful. And so what we're going to do is move in here and we're going to start to really build out how do we achieve that high consequence event. We're going to come up with our attack scenarios, 1, 2, and all the way to N, right? Think diligently about the people who might be trying to compromise your business and how to better defeat them. And then what we're going to do is we're going to have our targets, right? These are things that are in your environment that are potentially or likely vulnerable. And then we're going to write out really good documentation using all of our questions, our manuals, and we're going to have a comprehensive list of the hardware, software, our configuration files, firmware versions, protocols, the operating systems, models, vendors, and the function of that device, appliance, or system inside of the business. That's your job as a cybersecurity professional, to be able to generate those great target details, and then you're going to write your technical approach. How do you have access, actions, timing, and what are the triggers? What are the triggers that are going to be concerned or considered, and how will you execute them? So you'll put in your targets for your organization, and then you'll come in and ask yourself, do you have enough details? I would highly encourage anybody who's going to be in this space and trying to do this work for your organization to really make sure that your target details are comprehensively and effectively documented. If you make a mistake here, it could be costly, timely, and disrupt operations. A cybersecurity professional's job is to keep a business running based on the computer systems that they have. If you don't have enough details, go back and continue doing research. Once you do, update your database system and then move back to those high consequence events and keep walking through this flow chart. Once you've got your high enough details, right, you're going to move in and you're going to determine what are the critical needs, the deployment, and the development of the exercise. So that's how you go and manage these components. And it's how you do a high consequence event. It's how you create a risk register. Right? Risk doesn't have to be obscure. Organizations try to make it obscure. And think about it this way: if you were cooking in your kitchen and something caught on fire, the risk is your house could burn down. So you should have a fire extinguisher in your kitchen because there's events there that could lead to a fire. So all we're doing is looking at how a system works and where that system and process are vulnerable to a malicious actor implementing some sort of compromise to disrupt your business and profits. So we've talked about those things. I'm coming back to make sure there's no comments that I've missed. Okay, great. And once we have followed those steps, right, we talked about systems and systems analysis. We talked about malicious actors and how we want to deter their efforts. And then what we're going to do is we're going to focus on the structure of how we're going to write effective policies for our organization. And we're going to come up here and we're going to understand what type of practice are we doing? Do we need NIST 853, 171, FIPS, HIPAA, CMMC, right? What practice are we going to follow for our organization and say, this is the framework and methodology we practice? Then you'll move to documentation. And documentation should be extensive and it should have those interviews, the diagrams, the events, the scorings. And that's going to let you build your requirements, determine the design, move to implementation, verification, and then maintenance of the security control that you've selected and why you are implementing it. So I'm going to stop sharing real quick and we're going to come over and we're going to, I'm going to pull up the board and we're going to sort of walk through selecting a control, assigning it to a team, and effectively understanding why we selected that control. So we're going to come in here in just a second and I'm going to pull up a list of how Catnate works and what it does. So this is coming up. Great. And we're going to share this screen again. Time screen, coming back with the sharing. Now, what we've got here is our risk assessment. And what we can see is we can see if there's exceptions created, our security and privacy attributes, our access control, our priority tasks, um, high importance controls, critical controls, training and awareness, controls that have exceptions. And we see that there's one critical control with an exception. So if we create an exception to a control, we've introduced risk to our organization. We can also determine the validity of our critical and high controls. This organization has 4 validated, 3 selected that haven't been implemented. So what we've got here is a list of every control that the organization has started to implement. And this is broken down by the teams who are most likely responsible. But let's determine what the actual settings are. We're going to take this, we're going to make it nice and big for us. Then we can start to really understand what's happening inside of our organization and what people are working on. So we see that we've got our executive cyber leadership, our knowledge manager, we have empty controls. So what settings do we have with this? Right now, our organization has grouped by teams that are consulted about a control. So what does this mean? Our cyber legal advisor was consulted about remote access and monitoring, session termination, identification and authentication. And we could go on. But maybe we want to know what team is responsible for the scope of work that they executed. So we're going to switch to that. And we see our knowledge manager has responsibilities. We see our cyber defense forensic analyst has responsibilities. And we could dive in and explore the control that they've been assigned. We have a description of the control they were working on. We have discussion questions associated with the controls, and we see that no secondary control was considered. So when we come back here and we are engineering or designing the security controls, right, we had to determine a couple things so we could detect a malicious actor, right? Proactive, detective, and responsive actions and controls, and that's what this actually looks like. This one has no secondary control to consider. The status of the control is inconclusive. The priority is medium. We see it was last updated. We have our requirements, estimated hours. We see that this one has an exception that has been required, and that exception impacts the investigate part of our cybersecurity framework. So when you think about risk, and if you introduce an exception, right, we see that that exception period was from May 22 through the 26th. So we had 5 days where our organization was potentially vulnerable with the investigative function of our cybersecurity framework. This control hasn't been fully sussed out, but it is an example. And then here we can really understand who's working on what team is responsible, what team is accountable, what team is consulted, and what team is informed as things change related to this control. So how is our accountable team of our cybercrime investigator doing? We can come in here and we can figure that out. We have a description of what they do. We understand the progress. We see that the rest of this hasn't been built out, but we could even send an alert to that team related to the control that we just talked about. This is really effective about communicating at scale without having to comb through extensive documentation, right? This alert is specially configured to send emails, notifications, customized to the people on the team, the people on call, and the people who are related to this group. More effectively communicating about what's going inside of your organization across 1,000 controls can feel overwhelming and daunting. So we don't need to let that happen. Additionally, if we didn't want to know responsible team and perhaps we wanted to know the status of a control, we could come here and group controls by status. This one's inconclusive. These controls are validated, right? A lot of risk management and GRC frameworks exclude the ability to examine controls and do not holistically account for how the organization is operating. Maybe if we don't want to know status, but we wanted to group by priority, we can do that. Maybe priority is not what we want. We just want to know where exceptions are required. We can also convey exceptions to controls, which is imperative when you're assuming and assessing risk inside of a business. So we see we've got yeses, nos, and controls that are under discovery. And if you don't want to know about the exceptions required, maybe we want to know about what group these controls belong to. So we can see how we are accounting in our organization for security and privacy attributes, or access control, remote access, right? We can really effectively communicate at scale about our security controls, integrating an effective framework, and solving the problem of miscommunication about selecting cybersecurity controls inside your organization. And we're wrapping up at the end of this presentation. So let's make sure we give credit to login. I'm pulling this up. I've got my notes. Just a moment. Try my best here. Yeah. Login business. They provide ultra fast business internet, VoIP, data and cloud, networking, and co-location. You can additionally see the data center that's behind me here. These services are available for small, medium, and enterprise businesses. Right? Voice, data, and even video services for your organization, along with co-location. So special thanks to Login for hosting this event, and we're glad you came, and we hope to see you next